I would like for you to title these membrane notes. So let's do that now. Membrane notes. I can identify 3 types of membranes. We're going to list those out. We're just going to do the characteristics of them as we work through this. 3 types of membranes. The first type is a non-permeable membrane. Permeable, that's an R. Sorry about that. Membrane. Non-permeable membranes act as a barrier. They do not let, or does, we'll just do it this way, does not let small or large particles through the membrane. Particles, it's an S, sorry about that. Go ahead and fix that while y'all are writing. Particles does not let small or large particles through. So it acts as a barrier. Okay, I'm going to make an analogy to raincoats for all this stuff, and so we're going to look at a rubber raincoat like you might wear, a rain slicker sometimes they're called, and those raincoats don't let anything in or out. So as you're wearing those coats and you go out and ride a bike, you are going to perspire a lot. There's going to be a lot of water vapor coming off of you, and it gets trapped on the inside underneath the coat. So you get this clammy, wet feeling. You'll get done with the exercising, and the inside of the coat is all wet, and that all came from you. And so we're going to talk about a guy that had listened in science class and now made a whole bunch of money, or at least a group of people. The second type of membrane is called a permeable membrane. Permeable membrane. Permeable membranes let large and small particles through. Large and small particles through. So that would be like wearing your cotton sweatshirt, like many of you probably have on right now. A cotton coat is very comfortable in terms of moisture and stuff like that, but it does not do a very good job for you in terms of keeping rain out. So you wear your cotton coat, you're just going to get all wet because you're comfortable because all the perspiration leaves you and goes out into the air, but all of the moisture that's coming in from rain or snow or whatever you're out in goes right through your coat as well, and you get all wet and stay all wet. The third type of membrane is a semi-permeable membrane. It can also be called, that's an A, sorry, it can also be called selectively permeable. And what they do, what's selective, like cell membranes, are selectively permeable. So sometimes it's useful to talk about what something isn't, and that's why we talked about non-permeable membranes and permeable ones. But this gives you an idea of what how a cell membrane operates. It's selectively permeable. Selectively permeable membranes, in general, will let small particles through. Keep large particles out. Large particles. Alright, what's this like? Well, once upon a time, I believe this was actually born in the town of Eugene, Oregon. I'm not positive about that. You could check it up, do your little Google search. But at any rate, there was someone that thought about how a cell worked because they listened in biology class, and so they figured out, hey, if I could make a treatment to a piece of fabric that acted like a cell membrane and was selectively permeable in a town like Eugene where people bicycle all the time in the rain, then what I could do is create a barrier, a membrane that I could attach to a coat, and then people could be out in the rain and be comfortable. And that person was Gore, and the product is called Gore-Tex. Not Al Gore, who claims to have invented the internet. This is Gore-Tex, the fabric treatment. Gore-Tex works this way. If you want to imagine this is a membrane that's on a piece of clothing, you can imagine that on the membrane there's just little bits of holes, very tiny holes that are in there. And sorry, kind of got to put those back in there. And then on the outside, out, and this would be in. On the outside, we have water, and the water droplets are very large compared to the holes in the membrane, where the perspiration is a gas. This is a liquid. Liquid has a much larger form than the gas particle does. So this gas would be equivalent to that little dot, or that little dot. So the gas, water vapor, can escape out, but the water bubble is the rain drop is too big to go in through the membrane. So it can't get through the little holes because of the surface tension of water. Tends to make water hold on to itself, and so it won't go through that little hole like that. But the little teeny gas particle from the water vapor, is small enough to exit the holes in the membrane. Look it up. Go to Gore-Tex's website. It's right on there. For reals, a guy that listened to science teacher, and now look at that. Enjoy.